red beds. And what happens as we go to our left here? Okay, so this is what would you call? So let's take a look at this sediment over here. And do you notice? Oh, there is some stratification. Where do you see the stratification?
There's a white line.
Yeah. What could that white layer be running through there? What would give a
white?
Somebody want to run up and see if you can kind of dig into that with your hands, or bring. Yeah, bring it down. Kind of pass some of that sediment around, and
very crumbly.
Very crumbly. Feel like, is it like between your fingers? Does it feel a little gritty?
Is it ashy?
Is it ashy? Here, so that's probably a volcanic ash layer in there. So what happens to the layers as they go over to the bedrock on our right that are tilted?
Sorry about that.
To that ashy layer?
Yeah, follow that ashy layer over. And then, so there's some more material underneath this. How's that stratified? Is that tilted?
No.
In the middle of this wash here?
Not really, but it does experience a small amount of tilting.
So it's inclined as you go over, and the thicker layer in the middle kind of pinches out as you go that way, but that white layer kind of traces up over it. So what would you call that contact where the white layer kind of traces up over these harder, tilted sedimentary rocks?
Unconformity?
Yeah, what kind of an angular unconformity there. So what do you think? Let's look at the sediment overlying that angular unconformity. What do you think that is, Axel?
There's some really soft white stuff over here.
Oh, okay. Is that the ash again, or?
No, it's even softer.
Okay.
Probably, my guess is it's more of the ash.
Yeah.
So what else do we have here besides the ash?
Is there any hints in the topography as to what this deposit might be?
Outwash fan, maybe?
Yeah, especially, let's go back across the road and look at it. So we have a little layer of sediment. You called it sediment rather than sedimentary rock, right? It's loose. Yeah. And that's underneath what? A little wash or valley coming from the side. So what age do you think that sediment is, the loose sediment? Quaternary. So we're seeing a nice cut here of what underlies the little washes and stream valleys. And of course, it's angular unconformity. The stuff on the right would be what's known as the Humboldt Formation, which gets as young. The youngest dates I've heard from it are around 9 million years, I think, 8 or 9 million. So it's Miocene. So it's not really very old. Of course, the Quaternary would be less than 2 million years. So in the last couple million years, where might be a source? Where's the nearest volcanoes where you might get a tuff source from? Very fine-grained tuff. Might be an airfall. What did you say?
Yellowstone?
Yellowstone. I think Art has, I don't know if this is locality, but he has discovered Yellowstone. That's Art Snoke, has discovered and dated Yellowstone tuff from this area. And so that's very likely. I don't know if that would be the Huckleberry Ridge tuff, but it's probably one of these Yellowstone tuffs, I would guess. And so we're several hundred kilometers from Yellowstone here, so that tells you have a distinct horizon here. That tells you how big those eruptions were. So let's go back and take a look at the Humboldt Formation. It's a deformation. Nicole?
Right here you have this like...
Speak up.
They're tilted first off.
Okay, they're tilted first off.
And then over here you have this kind of like, I wouldn't say wavy, but something's going on here.
Okay, some offset in some of the layers.
And you can see the...
Can you say, right. So can you point out a fault or a offset? Right, so perfect. This pulled apart, which makes sense for the Basin Range province. The only other thing I see here is a lot of kind of vertical, subvertical jointing, which also, that could be, that would be tensile fracture, probably formed those, and that could be extension related too. And so there's quite a few faults. How about the quality of the sediment? First off, what color? Yeah, pretty dark. We call these, generally we call these red beds, right? And what's that indicate about the environment?
Iron rich.
Yeah, not just that, but more, is the iron in it oxidized or reduced? Oxidized, and that's typically is this a submarine environment?
Yeah.
Yeah, right, underwater? Do you think? Red beds, what do they indicate? Exposure to what? What oxidizes things? Oxygen, right? So it's subaerial exposure. So they're out of the Carlton, out of the road?
I thought the Humboldt Formation was basin deposit.
Yeah, right. So, but it's terrestrial, right? So it's the same kind of, probably similar environment to what we have today, red beds. You typically are thinking subaerial terrestrial exposure. What else tells us that? So what's our variety of different types of sedimentary rock here? So you have conglomerate, alternating mudstone, sandstone. So you said transgressive versus regressive. In this kind of terrestrial environment, how might you, there's another way you might get an interlayering of like sandstone and mudstone and such. And conglomerate be very...
glaciation maybe?
Well, the...
outwash?
Well, it's more likely, I think, it's just facies changes. So you're like, what kind of environment might you picture for this? I think about today, yeah, desert.
So
Floodplain?
Okay, so a floodplain might give you mudstone, overwash deposits. You might get channel fills.
Silt levees?
Now these are fairly extensive, thin layers. You might get debris flows, some of the coarser layers. And so especially as you get into the more, like that huge up at the top, I don't know if anyone got up high enough to look at that, or maybe it comes down toward the road over there, but that's more, anyone get a look at that? So that more massive layer, it was more gravelly. Might be a debris flow coming down out of what? Nearby mountains.
Like an alluvial fan?
Right, so it may be an alluvial fan building out into a basin. So alluvial fan, basin transition or something. So not necessarily all that radically different than what we might see today as you go like at a more distal ends of the alluvial fans.
And so
It's
what
like-
that would also then imply, obviously, is that when these were being deposited 16 or 9 million years ago, you had to have a lot of topography.
Yeah, right.
You're going to get that much sediment mobility.
Right, and so yeah, the sorting of the conglomeratic and the sandstone layers, you'd want to look at things like the angularity of the class, right? It's the sorting,
And the lithology of the class.
right,
We know what
right.
has been up there.
And so we might want to look in, and one of the things you would do if you were, you might, in terms of building up the sedimentary tectonic story, you might come in and do class counts, look at, are we seeing metamorphic class yet? So you would, there are quite, we don't see them here, I don't think, but there's quite a few tuffs interlayered. Once you hit 17 million years, that's when the Yellowstone hotspot first begins cranking out tuff layers, and so they give us this kind of clock, sedimentary, interlayered with the sedimentary sequence for recording the history over the last 17 million years or so. And so you can find older tuff layers, date them, and you can look at where in this sequence you begin getting metamorphic class shed into the basin, where in, and it's around, now the Humboldt Formation that I've seen farther north you just begin to see some wood hills looking metamorphic clasts, maybe 1%, very rare granites and so forth, up around in rocks that were more like 15 to 17 million years. And you don't really, in many cases, you do not see, I think here, in this area actually, there may be some high-grade clasts, like the migmatites we've been seeing shed into the basin, but overall in the Humboldt Formation, most areas that I'm aware of, you do not see those high-grade metamorphic clasts that would have come from the East Humboldt Range or the Ruby Mountains until you get to the younger Quaternary deposits. So if you went and looked at those Quaternary deposits, you very likely would begin seeing gneisses and maybe granites and so forth. But if you look at the class counts and did class counts in these conglomerates in the older Humboldt Formation, the Miocene Humboldt Formation, you're likely just seeing sedimentary rocks, a variety of sedimentary rocks, and maybe a few type wood hills type metamorphic rocks, but nothing like we're seeing here. And so what's that tell us about the modern mountain range front? I've said the word actually. It's modern, right? Yeah, it's probably, we really didn't get there. The high-grade metamorphic core complex doesn't look like it really got uplifted and was very seriously shedding material debris into the adjacent basins until Quaternary time. So it's the uplift may have been quite young. A lot of the uplift may have been quite young, and in fact, it's still, we can see active scarps on the mountain ranges is still going on today.
Yeah.
So,
but the class would give you a view of what was there on top of the metamorphosis, right? Yeah.
right. And so,
they call these things unroofing sequences.
Right.
You can look at whatever is the oldest class deposited must have been the highest on the sequence and vice versa.
Yeah. Hi, Al. Hi. So.